Alright, so what does FAR say we're doing anyway in terms of 15, Mach 15? I don't know what the speed of sound is on Mars, but okay. Lift, drag, dynamic, what am I looking for? Fuel fraction, I'm looking for, there we go, lift drag number. Just 0.2, really? And what is our ballistic coefficient? 100 kilos? It's not terrible, right? What are we? We're a little under half a ton behind a 2-meter heat shield. Looks like it's working pretty well. Ballistic coefficient isn't too unhappy. The ablator seems just fine. Just needed a nice light coating. That's good. So, yeah, just losing speed. Alright. Well, that's nice. Close that. So now we're just heading uphill gradually. We're approaching our apo, and then we're going to kind of dip back down. Looks like we're going to probably end up landing at night, hey? I can probably get rid of that. This looks like we're not at risk of any temperature explosions. Just have to keep this orientation though. So yeah, we're really dropping in terms of G's. We're still moving pretty fast though. Use a little bit of the fuel from this. We've still got almost a kilometer fuel, so I don't think we're at risk of crashing at all. Oh man, I don't know, I definitely like the atmospheric look. It's kind of dark out there, just a little bit of haze there. Just this, you can really tell it's this thin atmosphere. Time to impact 2 minutes away from death. Oh, vertical speed is increasing. It looks like we don't have much lift on this thing at all, do we? I mean, it's enough to, it's kind of enough to steer to capture. I wonder if that would be enough. Just use that for your computer for a real craft. So maybe we might actually want a higher lift drag ratio, because here it looks like we're pretty low. Time to impact, suicide burn. Seems like, well actually, maybe now that we're no longer like supersonic, we're really slowing down. What is our lift drag ratio? And it still reports very low, so I don't know. I'll have to look. Maybe our ballistic coefficient is just enough in itself that we're going to be slowing down a good bit. We're falling faster and faster. I mean, it's a small amount. We are getting a higher G-force all the time though, so there's that. Still decelerating at almost an entire Earth G. There we go. We're going to lose the sun over there. Actually brighten up my own actual monitor just so I can see what's going on at that point. There we go. And the sun's just going to go away pretty soon. I wonder whether this has a flare. Ooh, neat. Mercury. That makes sense. Mercury just near the sun. Alright, so a minute till we hit the ground. We're now moving slow enough. Oh yeah, there's got to be a way to jettison you. But anyway, let's see. Will the parachutes pop? I armed them. So let's just take a quick look at what it says for their data, and I can reflect on this in the pre-deployment altitude. Oh, okay. So, true altitude. Oh yeah, that's true. I mean, we are moving fast. We are still 16 kilometers above the ground, so fair enough. Yeah, I don't know, our ballistic coefficient just seems to be just a freaking winner here. Winner, winner, chicken dinner. Now, hopefully both chutes go the same way. Okay, so now we can see what the G-force does. So that's just not going to be enough drag to pull away from the heat shield, and we haven't done any crazy things that'll force the heat shield to fly away. But when those go, where are we now? 53 seconds. So if I do that, what does it say? 27 seconds still in terms of. Alright. And what about, can I put these out with it? Those are going to clip. Let's pull that back. Try to hold the ideal orientation. Oh, something's, there we go. We're really starting to lose control now. And those tiny chutes just pop out. Get a bit more G-force. That's nice. Let's see if we can jettison that heat shield. Oh, it looks like it went away. Well, that's nice. That's ideal. Seems like these would be too small to really help, but who knows. Does FAR calculate the ballistic coefficient for those? Maybe. Should have to look though. 3 something. Something surface. 29 seconds to smashing into the ground. Are these throttleable? I can't remember. I don't think they are. I can just close the FAR display. We're moving pretty slow now. 23 seconds to smashing the ground. Looks like 9 seconds. See, I don't think these throttle. No, but I mean, they can pulse, so infinite relights. That's the benefit of those. And they're burning, what? Cavia? Oh, yeah, I want those on now. So without that, yeah, we're accelerating without that on, without the chutes. So I'll probably want a hotkey to get rid of the chutes. I think it would make sense to just to cut them at some point. Okay, 3 seconds from the ground, 2 seconds, 1.5 seconds. The RCS is giving us a puff, but I suppose we're using the RCS to hold our orientation, so I think that's fair. 5 seconds to hitting the ground. Frame rate is just abysmal. Can't really even see. Oof, we're moving pretty fast. Weird. Well, I mean, that worked. I mean, don't really know how, but it worked. And we'll extend the solar panels. The solar panels shouldn't necessarily matter because it looks like we were able to retain our 100-watt generator. But yeah, we've got half a ton on the ground here. That's not bad. About half. That's not unreasonable. Half of our mass that we threw towards Mars got to the ground. It's not unreasonable for a mission in this era at all, I don't think. Now, of course, it's. I think I oriented these solar panels like absolutely the worst for that sunrise, sunset. But hey, that's fine. Yeah, didn't use too much of our fuel. About half. It's not bad. So just close up all these. And we can see the planets. We can see Venus. We can see Jupiter. We don't see Earth, but that's okay. Earth is necessarily going to be visible. I can see Uranus. Yeah, so we got our landing, which is what we really wanted. Whoa, no. Can we lock the legs or something? Weird. Maybe I should. No, these weren't on a hotkey. Before it just explodes and does something crazy to itself. Where is the... shit, that not, oh, there it is. Start. Alright, so in theory that should slowly but surely pull in CO2. And it is. So this is the ISRU test. This is the absolute very beginning of our, this is basically the technology test of our Mars Direct. First, can we send a lander to Mars successfully and send a air filter that can suck in carbon dioxide? It's not liquefying it at the moment. It's not. I might send it with an electrolyzer. I'll have to look up the exact name, but zirconium electrolyzer, something like that, which will take the carbon dioxide in, separate it into carbon monoxide and oxygen. Even just storing those as gases, honestly, would be a fine demonstration. And then we can do a liquefaction test, send a liquefier and a Sabatier on a larger lander or a later lander. Maybe it's not going to be much larger than this one, but basically just again just a chemistry demonstration, which might lead to a sample return or what. So let's just time warp, and we get whole liters of gaseous CO2. Doesn't seem like much, but it is important to be able to suck CO2 out of the atmosphere on Mars. It's true. I might need to check with some way to separate the CO2 specifically. Is it going to gain weight overnight? I wonder. 503. Oh, and there we go. We go through a Martian day. So this is where we landed. Lovely spot on this dune right here. All the gaps visible and the crazy shadow that it likes to produce. So there we are in this just plain of Mars. These little dunes as we're zoomed in. 503, yeah, and it's just pulling in carbon dioxide. Not enough to gain weight, just 1,000, oh, there we go, gained a whole kilogram of CO2. in a couple of days. But I mean, that is kind of the technology test that we wanted to demonstrate.
Well, I've still got a lot. I have maybe over